So let me remove this one. I actually prefer this one as a window right here. Let's start doing our process. We start with a cooler. So let us choose the cooler or chiller, and we'll be here. We can zoom in, zoom out, and the first things we need to do is to state the name, the inlet, let it be pre-feed, energy, let it be chiller duty, and the outlet, let it be feed for the next step right here. So we click enter, and all the stated or required feeds are now present. Now pre-feed, we're going to fill it up with our conditions. So we know, as the process stated right here, we need a composition of this right here. So let's go to the composition tab, methane. We need 2883. The isopentane 2402, and the dodecane is 4715. All other material is 0. So stated OK. Ensure this is mole basis, and go back. We need to state temperature. As stated is 30 Celsius at 506 K. So it's 35, not 30 Fahrenheit, and 10. Okay, what else? The mole flow will be 100 kilomole per hour. So you can see, because we stated the temperature, pressure, total mass flow, and composition of this stream, this converts into a, let's say, it's no longer a variable, it's now fixed. This is blue, which states that in order to change either chiller or feed, one will change as well. So if you give a heat duty, then the feed must be calculated. If we give the feed, then the chiller will be calculated. Now let us state that we do know that the chiller will decrease the temperature to 15 Celsius, and we assume that the delta pressure is about half an atmosphere. Perfect. Now you can see, because we stated the variables, now everything is fixed. Because we stated the temperature, we have inlet temperature, outlet temperature, we have compositions. So the compositions are fixed because it's inlet, outlet the same, there's no reaction, and the heat duty is now calculated. So that's what we need to do in order to state the chiller or the cooler right now.